Good afternoon, everyone. Welcome to the very first lecture, first programming lecture of our single variable calculus series. Now, first program we are going to write 4 to 5 programs in this lecture, and the first program, Python program, we are going to write is to calculate the derivative of polynomial functions, right? So we are going to import SimPy library of Python, right? And we are going to write every code in Python. Okay, and I'm going to declare x as symbols. Okay, what this line means, and just what it means that now after writing this line, x will be the symbol in some py. What it means that now I can create a function using this x. So now x is a mathematical variable. After writing this line, x is a mathematical variable. So I can write function x to the power 3. Double star means I'm 3 is the power of x. If there is a single star, what it means, there's 3 into x, right? This is x to the power 3, right? And I can write 2 into x to the power 2 plus x, right? Now I have defined the function I mentioning over here, right? The define function. So this is the function of which we need to calculate the derivative, right? Okay, so now calculate. Okay, I can write only derivative over here. Okay, so now I need to store the derivative of this function into another variable. I am going to name that variable name fx. Okay, fx, what fx is? Fx is the derivative. This is the variable name. You can name it anything, right? So what I'm going to write is sp.def. sp.def is the function which calculates the derivative of the function which we are going to pass into it. We are going to pass f, and what we are going to tell that calculate the derivative of f with respect to x. So the first parameter we passed is function, the function of which we need to calculate derivative, and second, with respect to which variable we need to calculate the derivative of f with respect to x. That's why I've passed the second parameter as x, right? Now but what we going to now is to just print the, right? First we print function x. Function f of x is, okay, function f of x is this, okay, f, right? And print, what is happening, print, and the f dash x, derivative f dash x. F, okay, I must use double string f dash x, derivative is, and string close, and we are going to print fx over here, right? Fx is the derivative. Now if I shift enter and run this program, what I found is that f of x is this and its derivative is this, right? You can calculate by hand that this is the derivative of this function, right? So second program, what we are going to see is finding the slope of tangent. And okay, first what we are going to see is using the sin x function in SimViewer, right? This is the program we are going to use sin s constant. First, we are going to import SimPy as sp. Now I need to symbols of x. X is now a mathematical variable. I can use anywhere in the function, right? I'm going to write a function f is equals to sp dot sin of x. Now what it is? This is the sin function, right? If I calculate derivative of it and print, I can, instead of fx, I can directly print it, right? I can write here derivative of sin x is, I am can write this thing as it is over here instead of storing into any variable, right? And close the bracket. And derivative of sin x is cos x, we all know. And shift enter, I can get cos x, right? So this is program to calculate the derivative of sin x, and this is how you can use sin x, right? Okay, so now uh, third program we are going to write is calculating slope of tangent at any point. So in this program what we are going to find slope of tangent at x is equals to 3. So first what we are going to do is to import simplify as sp. We are going to use simplify library, right? So first thing I need to do in every program is to create symbol x, means mathematical variable x. Now below I am going to declare a function. Now function is the curve, and we want to find the slope of the tangent at point x equal to 3 at the point of that curve, right? F is equal to, let's write x cube x power 3 plus 45 into x, right? Now you must know that the slope of the tangent at any point x is f prime x, right? So first we need to calculate, okay, slope at arbitrary point x is derivative of x, right? So let's first calculate derivative. Let's name it df. Df is equals to sp dot symbols and sp dot def. I'm going to write f and x over here. Now what it returns, that it returns the slope of the function at arbitrary point x, right? But what we need the slope of tangent at point x is equals to 3. So if we substitute x is equals to 3 in different in this expression, then we are going to get the slope of the function tangent at x equal to 3, right? So I'm going to write over here slope of tangent at x is equals to 3 is f prime of 3, right? That it must you know from our previous lecture, right? So I'm going to write here slope is equals to, I'm going to write here df dot subs, and I'm going to write here x, and I'm going to write here 3. Now let's create a, now let's say x1 is the point at which we need to create we want to find the slope of the tangent. So I can write here x1. First, what it means, this what it means, that slope is equals to df. Here is the df. Substitute x1 in the df in this function. I am substituting x1 instead of x in this function, right? So what I am doing is I am substituting x1 in the derivative of this function. So it is going to give me the slope of the tangent at point x1, right? So now I just need to print three things. First, derivative. Derivative is a slope of tangent of the function at an arbitrary point, right? We are calculating it at a specific point. Derivative of f, and I can write here is df. Second thing I want to print is slope at x1 is equals to 3. I can write here slope, right? And anything else I must print function. Print f is, and I can print f over here. So dot subs means substituting value in the function and getting a resultant value, right? Okay, so what it is doing is substitute and calculate value of derivative of f at x1. Substitute x1 and calculate derivative of f at x1, right? And if I press enter, so on what I get, f is this, and so that derivative of f is 3x square plus 45, right? And slope at x1 equal to 3 is 72, right? You can see that 3x square, right? 3 into 9, 3 into 9 is 27, 45 plus 27 is 72, right? And we are going to write third program is finding equation of tangent. What we know that equation of tangent is must going to be like this. This y is equals to some of the form like this, right? And if I elaborate more, then equation of any line is y minus y naught is equals to m. M is the slope of that line and x minus x0, right? So for finding the slope of the equation of tangent, we need to find the derivative so that we can find the slope of that tangent. And so below I have copied this thing over here, and what we have done is we have calculated the slope at x1 equal to 3. Now if I want to find the equation of line, so what will be that? The equation, let's say I'm going to write equation new variable. Equation is equals to okay, first I write in as okay. So equation is going to be, if you look at here, is equal to be y0 plus m times x minus x0, right? This is the equation, and what we need is right hand side of the equation. I've I've written here equation instead of y. So what we want is only the right hand side of the equation. Left hand side is going to be f of x, right? So here y is equals to f of x. We all know f of x means this f, right? Okay. So now I'm going to create a variable equation. Equation is going to be the f of f dot subs. I am going to substitute x1 instead of x1, right? Plus I'm going to write here the slope of the tangent multiplied by, I'm going to write here x minus x1, right? So what it means that I am calculating, I am deriving the equation of tangent at the at point x1 on the curve, right? So what it is, you can see here equation is equals to f dot subs x1. What it means that is f of x1, and slope means f prime of x1, and into, and this is the x minus x1, right? And equation here is f of x, right? So what we are going to do, we have just found the right hand side of the equation. Left hand side we already know that it is f of x, right? So I am just going to print that equation, that equation of tangent is, I'm going to write here equal is the variable, right? If I run this, so this is the equation. What it means that 72 into x minus 52. What it means that the equation of tangent is y is equals to 72 into x minus 54. Now when I said here y, we know that the left hand side is f of x. Here f of x means the tangent, right? Y is the tangent, not this f, right? Okay. Now, oh, okay, right? Okay. Okay, now next program what we are going to do is to drawing the graph of sine x, right? So for drawing the graph we use matplotlib. This is also a library as MPY, right? Matplotlib we are going to import is, and I am going to give it a nickname PLT. Now I have imported matplotlib, right? Now I'm going to import simpy as SP, and I'm going to import another library numpy as NP. So now first whenever we import simpy, we first thing we are always going to do is to create a symbol, create a mathematical variable x. Now f is equals to sp dot sine x. This is the sine function, and I am this is the symbolic function, right? Symbolic. This is simpy function, symbolic function. Now we are going to create another function which is fnum is equals to sp dot lambdify. I'm going to write sp dot lambdify, and I'm going to write here x f, and going to write numpy. What it means that converting symbolic into numeric function. What I'm doing here, I am converting f. In f is a symbolic function. Simply always deal with symbolic function, right? I am going to convert into numeric function. So now what we are going to we want to draw the graph, right? We want to draw the graph. For drawing the graph we need x values, right? We need x values, we need right values, y values, right? Y values is just sine x, right? Okay, so now we are going to create x value. X values is the values of x for which we are going to mark the point on the graphs, right? X values is equals to, I am going to write here np dot line space, np dot line space. I'm going to write here 0 2 into sp dot pi, sp dot pi, and np dot pi. Okay, sorry, np dot pi, and I'm going to write here 100. What it means that 0 to 2 and pi, this is the interval, right? 0 to 2 into n into pi. I'm going to write only pi over here, right? Pi 2 into pi. What it means that 0 to 2 pi, we want the graph of this function in the interval 0 to 2 pi, right? So whenever x value changes 0 to 2 pi, we want the graph. So in our graph, the values which we are going to see is just 0 to 2 pi, right? And what it 100 means? 100 means we are going to divide 0 to 2 pi interval in the 100 equal pieces. So what we are going to do is to calculate the value of sine x, at 100 points between 0 to 2 pi. So this is just gives us 100 points between 0 to 2 pi, right? So 0 to 2 pi. Okay, so I'm creating 100 points between 0 to 2 pi, and now y values will be sine of these values, right? This is 100 points and we want y for that values. So y values is just sine. So I'm create fnum, and I'm going to write here x values. Return what it gives it gives us values of sine function at x values. So for every x values, what it gives the sign values for that x values. So now I am going to write plt dot plot x values and y values, and we can label it. But okay, what we are not going to label it now, but I'm going to write plt dot show, right? Plt dot plot is used to plot two variables. Here one is y, which depends on x, because y is f num of x. I cannot write direct f of x, because f is a simplify function, right? And f num is the numpy or numeric function, so I can write f num of x values. So now if I run this program, okay, but here x values is not defined. X values, okay, x values, right? Okay, if I run again, what it means, the module matplotlib has not pyplot as plt matplotlib dot, okay, live plot. Okay, so what we need to import is pyplot, not only matplotlib, right? Okay, is I press shift enter, so what I get is 0 to 2 pi. 2 pi means roughly 6. So I got a sine curve between 0 to 2 pi, and you can see here that curve here. So what we have done here, so what we have created a function sp.sinx. This is the sine function. We have converted it into the numeric function. Then we declared our x regions and y regions. In x regions we calculated the 100 points between 0 to 2 pi. np.pi is a np.pi is just a variable pi inside numpy. In numpy, if we want to tell that this is the pi, what it means is 3.40, right? So we write np.pi, so numpy understands that this is the pi, right? We calculated 100 points between 0 to 2 pi, and we calculated y values for this all 100 points. And what we have plotted is a value plotted. The x values means 100, these 100 points, and y values, this means this 100, and these 100 points are value of functions, value of this function at these 100 points at corresponding points, right? So this is the how you can draw the graph of the sine function, right? Now that is enough for today. Now I want to show you the graph of sine of 1 over x function, right? Now we have seen the sine of 1 over x. I'm just going to copy this. I'm going to change here. I'm going to replace x by 1 over x, right? And if I enter it, you can write any function you want to plot. Now if I shift enter, I'm going to get the graph sine of 1 over x, right? So you may know that graph of sine of 1 over x oscillates infinitely near zeros. Graph of sine of 1 over x oscillates infinitely, right? So that's why you are not getting a proper graph over here. We are going to see in tomorrow's lecture also, but I just want to show you that how it draws the graph of sine of 1 over x. You must notice here that sine of 1 over graph is not a wave, uh, not a wave at larger x, at x greater than, you can see here 1, right? Okay, so that's the thing you need to notice here, right? Okay, that's enough for today. Thank you for watching this lecture.